We're continuing with section 2.5, piecewise defined and absolute value functions. So how do we evaluate the limit for piecewise defined functions? Here's the little note. Piecewise defined for each piece is elementary within its domain. So for example, over here we have one piece that is elementary within its domain for x less than -2, and sine of x is again elementary between -2 and 0, and so on and so forth. So if each domain, if you drop the endpoints for each domain, then the function follows the elementary piece that is in that piece of the domain, and the limits are just direct substitution. So for example, if I want to find limit at x equal to -4, I know -4 is in this piece, and therefore I use limits of f of x as x approaches -4 is just direct substitution in that piece, which is -4. And so on and so forth. And so now, what about the endpoints? We just talked about when we drop the endpoints. So endpoints are a little different. Every endpoint, let's say -2, you go to the points that are directly to the left of it and the points that are directly to the right of it. So the limit of f of x as x approaches, let's say -2, from left is going to be direct substitution and the points on the rule of the function, the elementary function directly to the right of it. So that would be -2. And then limit of f of x as x approaches -2 from the right side is exactly plugging into that one, which is sine of -2. And these two are not equal to each other, and therefore the limit doesn't exist at -2. And we can see that there is the gap between them, so there is a jump. Now, if you want to examine the limits at the other breaking point at 0, this time what is exactly to the right of 0 is this rule, to the left of 0 is this rule, and to the right of 0 is that rule. And so limit of f of x as x approaches 0 from the left is going to be plugging 0 into that, sine of 0, which is 0. The other side limit is going to be plugging it into -x², which is 0. These two are equal to each other, therefore the limits exist and is equal to 0. And so this is for breaking points. You have to do a left limit and right limit. Each left and right is going to be a direct substitution. And so you can try at 2 also. The left limit at 2 is going to be -4. The right limit at 2 is going to be cosine of 2, and the two of them are not equal to each other. That's why the limit doesn't exist at 2. So now, what about absolute value functions? They're really secretly piecewise defined functions. And so what you do is basically, let's say we have absolute value of x minus 1. You write negative the inside if the inside is negative, and positive of the inside if the inside is positive. See, x less than a means that x minus a is less than 0, and x bigger than a means x minus a is bigger than 0. And so this is how you write it, and then you treat it exactly like a piecewise defined function. And noticing that each piece is going to be elementary. And so keep calm and carry on with the absolute value functions.